This is another skill video for the Unit 4 Skill 5, Systems of Inequalities. And today we're going to take it a step further with a combination of some different kinds of inequalities. We'll have linear and absolute value inequalities. So you might remember that with a system of inequalities, we are looking for the overlap of these shaded regions. Okay, so we have these graphs with some shading, and we're looking for where the shading overlaps, and that's our final kind of solution region, and we shade that nice and dark. Let's go ahead and look at this first example, and I'm going to include an absolute value function. So the first inequality is y is less than x plus 3. And the second, this is our absolute value inequality. Y is greater than the absolute value of x minus 1. Okay, and let's make a grid off to the side. Okay, so I'm going to start with the linear inequality at the top. We have a y-intercept of positive 3 and a slope of 1, right? Up 1 over 1. So I'm going to get some points on here. Up 1 over 1, also down 1, back 1. Trying to do this as much as I can across my grid. We should have a dashed line, right, because there's no equal to sign. And that just means that this boundary line, we're not including the points on this boundary line as part of our solution set. Okay, it's just the boundary. And since y is less than, I know that I'm going to be shading down. So sometimes, since I'm at the end just looking for the overlap, instead of doing a ton of shading right now, sometimes I'll just draw little arrows like this, just to know that in the end, I'm looking to shade only what is below that line. And now I'm going to move to my second inequality, which is this absolute value inequality. And you might remember that the number inside here with x, we do the opposite, and that is the horizontal shift. And so a minus 1 actually means to the right 1, and that's our new vertex of the V-shaped graph. So we're at 1, 0, and then the slope, remember we find it out front and it's just a 1, and so the V-shape graph, it's also this slope of 1, and it goes in both directions, so up 1, back 1. Okay. Because we don't have an equal to sign, these are also dashed lines. So I'll do dashed lines to the edge of my grid. Okay. And the greater than sign means that we should be shading up above this V-shaped graph. Okay, so sometimes I'll just do, again, like arrows like this. And then we look for that overlap, right? And so the overlap is below the red line but above our blue V shape. And that ends up being everything in this space here. And so I do a final shading of that part of the graph, and all of the points within that space are in our solution set. And so that's our final graph representing that solution set. Let's take a look at another example. Okay, in this second example, our first inequality will be y is greater than or equal to negative 2. And our second inequality will be y is less than or equal to the negative absolute value of x plus 3 with a plus 2 on the outside. Let's go ahead and draw our grid. Okay, I'm going to start with this top linear inequality. And in fact, this is just a constant. There is no x variable. And so those are always horizontal lines. So we're down at -2 for y. And this is just a horizontal line. And because we do have the equal to sign, it is a solid line. So we're going both directions, solid horizontal line. And because of the greater than sign, we will be shading everything above that line in our final shaded solution region. Now for our absolute value inequality, remember that this plus 3 inside the absolute value actually means we're going to shift left 3. The plus 2 at the end means we shift up 2, and so that's affecting our vertex, right? So our new vertex is now going to be left 3, so -3, and up 2. So let's go left 3 and up 2, and we land at our vertex. And then the negative out front, remember that means a reflection. Okay, it's going to be flipped upside down. It's still just a 1 out front, so we still just have slopes of 1. So down 1 and out 1, down 1 and out 1 in both directions. Okay. Our inequality symbol does have the equal to sign, so these are solid lines. Okay. And since it's a less than, we'll be shading down below our V shape, which is kind of inside that V shape. And so you can kind of see here that the overall final shaded region, where the two shaded regions overlap, is what's inside here, right? Above the red, but below the blue V-shaped graph. And so our final shading is just everything in this space, and that's it. Let's go ahead and look at one final example. So for example 3, let's start with one inequality being y is less than 1/2 x plus 2. And our second inequality is y is greater than the absolute value of x plus 2. Okay, and I'm going to get a quick graph going. Okay, so I'm going to start with the top linear inequality. I know that it has a y-intercept of +2 and a slope of up 1 over 2. Okay, up 1 over 2, and I could also go down 1, back 2, down 1, back 2, and our inequality symbol does not have an equal to sign, so it's just a dashed boundary line across the grid. Okay, so again, the points on the line are not a part of the solution set. Okay, and the shading should go down, right, because of the less than symbol. So points within the solution set are only points below this line. And now we'll go ahead and graph the absolute value inequality. We have this up 2 here at the end, right? So our vertex just shifts up 2. And then the slope is just that 1 out front, right? Up 1, over 1, up 1, over 1. And then we flip that over to the other side. And the inequality sign does not have the equal to, so again we have just dashed lines. Extend those out. Okay, so again, the points on the V-shaped graph also are not included in the solution set because it's a dashed line, not solid. And we have a greater than sign, which means we would be shading up above the points of this V-shaped graph. Now, as we look for an overlap of these shaded regions, we realize there's not one, right? They do share this point right here, okay? They both land on the point 0, 2. However, because we do not have both solid line graphs, that point actually is not in the solution set either. Okay, if these were both solid line graphs, that point 0, 2 would be the only point in the solution set. But here, we have a no solution. Okay, there is no overlap of the two shaded regions, and so there's no solution to this system. So I wanted to make sure to show an example of this scenario. So now you'll get an assignment with some practice problems involving linear and absolute value inequalities to graph together and to solve the system by showing that shaded region of the overlap. Okay, so good luck.